So welcome back, guys, and a very good evening to you. And we are here with our Thursday problem-solving session, and we are meeting after a long time, I guess, after the vacation of Puja and Navaratri over here. Okay, so coming back to the preparation, we have almost exactly November, December, January, and a bit of February. So 3.25 months left. So I think this is the most important time, just like this last over of a cricket match. Okay. So this is the most important time, and whatever you do in this time, this will determine what will happen in the next 1 month. So this time is super important. Okay. So don't devote the best part of yours during this next 2 to 3 months. Okay, that is super important. I mean, based on the data I have. Okay, so now during this time, I will ask you to focus a little bit on the like a bit less on the knowledge part, because now in the last 3 months you have to focus on a bit of the exam perspective, and we have covered everything in probability till probability, and this is the most important part. So make sure your knowledge is totally good in that, and statistics will be done, and it will be totally easy for you if its probability is really good for you. Okay, it's totally easy. I mean, that's the only reason you can learn statistics on your own. Perfect. So let's get started, guys, and we will be discussing certain doubts of the students out here, and let's see what doubts people have. Also, Nikhil, I think the problems you have given over here are from mathematics crash course. I hope, right? So it is suggested please discuss the problems in the group, or it's like I mean it's really useful in the group or in the crash course group. I don't know if you have it or not. It will be really useful for the people out there. Okay, if not, I will add it over there. Okay, okay. I will just check. Okay, I will just check. Um, so let's start in an alphabetical order, and I will do one problem a doubt from each. So first comes Tishika, Dev, Suryank, Nikhil. So Dev once comes first. Okay, so I will not spend too much time. Okay, and I will not spend too much time. It's like I will spend as minimum as time as possible, because past few doctorings were too long, lengthy enough. I felt that I am really sorry for that. Um, okay, so this is a problem that is given by Dave, and it's a doubt clearing one. So x and y are two random variables on a common probability space. The sample space, the sigma phi, the set of events, and the probability function. Is it possible that x and y have the same distribution, yet p of s given y of s not equal to? Okay, so it essentially means that the probability of the set of s or x such that, or rather s such that s yx is not equal to ys is equal to 1. What it means is the following. It means that first of all, this type of questions will not come in IIT JAM or ISI, but I will just make a quick argument on this to waste less amount of time. So it means that probability x is not equal to y is equal to 1 or not. It's asking whether this can there exist two random variables x is equal to y is not equal to 1 is 1 or not. Rather, probability x minus y is not equal to 0 is 1 or not. Okay, and so they have the same distribution is given. Okay, x and y have the same distribution, it's given. Okay, so yes, it can totally be possible that it's equal to 0, it's not equal to 0, it's not equal to 0 is equal to 1. I'm not sure about that, but of course we can understand that x minus y is not equal to 0, can be less than 1 and not greater than 0. Okay, so this is almost you're sure about that, because let's say x is uniform and y is uniform and x minus y is something else. It's another continuous distribution. So x minus y is another continuous distribution. Is okay. So it's equal to 1 if possible. See, so x minus y is another continuous distribution on 1, 0, 1, right? So probability x minus y a continuous distribution is therefore probability x minus y is equal to 0, is equal to 0, because it's a continuous distribution and it's equal to 0 must be at a point is 0, right? So therefore x minus y is continuous distribution and x minus y is equal to 0 is 0. So therefore x minus y not equal to 0 is 1. You understood the idea, Dev, and all of you?
Means x and y have same distribution, means the distribution function is same or it follows same, means what does that line means?
What does distribution mean? What is the only thing you know about distribution in probability, Paulami? See, I will tell you one thing. During these 3 months, I will be very, very strict. Okay, so I may sound a bit rude, but I will be very, very strict because I don't want to take things very carelessly now. So tell me, Ptolemy, what is the only thing you know about distribution in your entire life of learning probability? Bolo?
Means the point x will take with that much probability, same way y
Tell
will
me the
take,
distribution definition. What is the only, when did you hear the only word distribution in your entire learning career of probability? You learned probability for 3 years. When what is the distribution mean? Did you know anything about except distribution function, Ptolemy?
no, this, yeah, distribution function only.
That means x and y has the same distribution function. That's it. Okay. And if x and y have same distribution function, so x and y are same random variable. Since they are on the same probability space, therefore it holds. Did you understand, all of you guys? Yeah. Others, did you understand? Dave, it's your doubt. I think it's your doubt or Ptolemy's doubt.
Mine.
Okay. Did you understand, Ptolemy?
Yes.
Are you sure?
Yeah, means I have got the question I asked. After that, what you did here, probability x minus y equal to 0 is equal to 0. That is okay. And it means you have taken an example.
Yes. So it's asking, is it possible or not? So it's possible. That's what I showed.
Okay.
Yeah. Okay. Yeah. So let's go to the next problem. So I'm doing it very fast because I think you guys have a lot of time spending with probability. Okay. So I don't want to. Next is Dave Patel, and then I think it's Nikhil. Yes, Nikhil's one. So let's do the first out of Nikhil. Um, so what is the infinite series value probability? Nikhil, you want me to focus on any one problem? Do you have some suggestion, or I will pick up randomly? Okay, let's do the first one only. Otherwise, let's not. Yeah. So it's a problem from the crash course assignment, and let's see how we can do it. So what is the value of the infinite series? 1.1 by 2 by 2.3 plus 1 by 2 square point 3. Okay. Okay. So how did you approach this, Nikhil? This seems to be easy. Why couldn't you do this?
Oh, actually, I got this one. So if you could just see the last question, that one is.
Oh, why didn't you delete it?
Yeah, I should have too late it became.
Okay. That SN convergent, that is fine. This is fine.
No, if you can, any of those problems you can discuss. Yeah, this one you can discuss. I didn't get this.
Okay. So check whether series this is convergent. If it's convergent, find the value of limit Sn. So how did you approach it, guys? How did you approach it? Sen plus 1 by 2 to the power n. n plus 1 by 2 to the power n plus 1 into summation of k from 1 to n to the power k by k. Okay. So let's say we want to convert it into a geometric part. So understand that k is always greater than equal to 1. You can easily understand that. So 1 by k is less than equal to 1. So this is less than equal to n plus to the power n plus 1 less than equal to this to the power k, right? Because 1 by k is less than equal to 1. And if you do that, why did I do that? Because I want to connect it to this. So if you get that, we get n plus 1. I don't know if we get something interesting or not, but I don't think we get something interesting. So it's we get to the power n minus to the power n minus 1 by 1. So yeah, we don't get something interesting. So we get that it's less than infinity, okay? Because n plus 1 is infinity. So that's totally fine. That's totally fine. We're totally okay with that. And let's see what else we have. Let's do the other one. 1 by k is greater than equal to 1 by n. You can easily understand it from here. And let me write it down. So I'm just doing general inequality stuff over here. And it's n plus 1 to the power n plus 1. And it's 2 to the power n minus. So 1 by n comes out. It's same over here. And there's a by n over here. Okay. And here there is no by n. It's 2 to the power n plus, I guess. It's 2n, right? I think it will 2 to the power n plus 1 minus 1. Yes. So these are the these are the two ideas you get. Okay. So 1 is greater than equal to almost, this is going to 1. Okay. You can easily understand this. This is going to 1. And this is less than infinity. So you can understand that this is actually greater than equal to 1. The limit is greater than equal to 1. That you can understand. Okay. But we have not got the idea till now whether it's something convergent or whether it's something divergent. So we have used the 2 to the power k wala stuff over here. Okay, let's do something else. Let's do something else. But before that, let's try to understand this numbers a bit deep. So summation k from 1 to n to the power k. So it looks like this. Okay, understand this. Looks like 2 to the power 1 by 1 plus 2 to the power 2 by 2 plus dot 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 2 to the power n by n. The thing is that okay, just give me a minute. Less than equal to okay. So let's try to understand manner. So I'm going to show you that we will fail infinitely many times in this. So let's see, we will equality 1 to n. So let's do the easiest stuff. I'm showing you this because these are the basic stuff that you will do always. Always. Just always. Let's do the other way down. Let's do 2 to the power k. So it's 1 by k. So 2 to the power k by k is less than equal to, understand it will 2 to the power n. So it's n plus 1 by 2 to the power n plus 1 times 2 to the power n into summation of 1 by k from 1 to n. You can easily understand that. Also here it's n plus 1 by 2 to the power n plus 1 into 2 to the power n into summation of k from 1 to n. It will 2 to the power 1, sorry, 1 by k. Okay, and you know that this will go to 0. You know that, and this will go to, I think it will go to, you can easily understand it will go to infinity. So nothing useful is coming out here. Nothing really useful is coming out. Did you try any other methods, Nikhil? Did you try any other methods?
No, like the same thing. I tried expanding the summation and doing it. That.
Okay.
Means
Okay.
the test ratio test or something like that will work.
I don't know. I don't know. So tell me, how will ratio test work over here? So ratio test is SN.
Means n plus 1 by n. Yeah, it's n plus.
Wait, let me just write it down. I don't know. Like, I think these problems will be discussed in your mathematics. I think it's a crash course problem, right, Nikhil?
Yes, like it's in the assignment, so I try to do the assignment. So that.
Yeah. So SN plus 1 by SN. Tell me, like, what it will be. Yes, SN
Means
plus. Yeah, bolo.
means Sn plus 1 n plus 2 by 2 to the power n plus 2.
By SN will be n plus 1 times 2 to the power n plus 1.
Means, after taking limit, that summation part will tend to ln of 1 minus x. Yeah, that series.
Wait. 2 to the power k by k n plus 1, and this will, yes, so this will go to, you can understand this is going to 2 half, sorry, right? And yeah, so tell me your observation, Paulami. This will go to as n tends to infinity.
Means some logarithm, I think ln 1 minus x. Or, yeah.
This is ln 1 minus
Minus,
x.
minus of.
I'm getting confused. So you're telling this is minus of log 1 minus x?
Yeah, means I'm not sure about the ln 1 minus x. Yeah, it will be 1 minus x. Or means if we expand the series, it will look like that 2 by 2 square by 2, 2 cube by 3.
Okay, so what is log ln 1 minus x or 1 plus x? Tell me the expansion. Tell me the expansion.
Means ln 1 minus x is x minus x square by 2. Yeah, minus minus and x minus x square by 2, x cube by 3, like this.
Okay, yeah. So minus of log 1 minus x is that. You're right. Perfect. Yes, and this will go to log 1 by 1 minus, क्या होगा? 1 minus what? One minus what? See, this series is,
Yeah,
it's not.
yeah, here x is coming to. No.
X is coming too, so it's not possible, right?
Yes, yes.
So we cannot apply that formula over here. We cannot apply that formula over here. So these are the problems. These are the problems we all face, and so therefore you can understand that this is sort of behaving very abnormally. And I'm not sure how to do this because I'm not sure. I'm looking this first time. So let me think about it. Just to give me a minute. This is half and to the power n by n, so kind of. So you can understand, let's take this term. You can understand it's like this. It's like this Sn, let's call it Zn, the नीचे वाला one. And Zn plus 1 is what? To the power n plus 1 by n plus 1 plus Zn, right? and therefore it's 1 plus 2 to the power n plus 1 by n plus 1 times Zn. Now you see what is this? You see what is this? देखो, Sn plus 1 by Sn, this one turns out to be this, and this is S to the power n plus 1 by n plus 1 plus Zn. Okay, that is this one. So Sn is what? Sn is nothing, n plus 1 by 2 to the power n plus 1 times Zn. So what is this? Can someone tell me? It's equal to 1 plus 1 by Sn. You see, all of you understood this. It's a beautiful one. Yes, you're right, Shantika. It becomes 1 by Sn. Did you understand this, guys? Nikhil, can you convert? Yeah, Nikhil, can you do it from here now? This is a beautiful form now. So we have got that Sn plus 1 by Sn is equal to n plus 2 by twice n plus 1 into 1 plus 1 by Sn, which turns out to be Sn plus 1 is equal to n plus 2 by twice n plus 1 into Sn plus 1, because Sn cancels. So can you get something out of here? So think about this. I think it can be doable. You see, this is a sequence problem now. It's not a series problem. You have converted a sequence problem, series problem into a sequence problem. So you have a sequence Sn plus 1, which is equal to n plus 2 by 2 into n plus 1 into Sn plus 1. And now you can what you can do is that you can use all the results of your sequence to understand this. This is really interesting, right? So how can you do this, guys? Any ideas? How can you do this? So you can easily understand it from here, guys. It's super easy. That this goes to half if the limit exists. This goes to half. This goes to L plus 1. And this goes to L if the limit exists. Okay. And therefore, L should be what? Twice L is equal to L plus 1. So L should be 1 if it at all exists. This goes to L plus 1. This goes to half. This goes to L. So L is coming out to be L plus 1. L is coming out to be 1. Okay. So we know that this is greater than equal to 1. In fact, it's not greater than equal to 1. It's greater than 1, I guess. No, I think it's greater than equal to 1. So therefore, do you feel that this is equal to 1 at all? Or do you feel it's increasing? Sn is increasing. So I think it's doable from now here, right? It's a very interesting problem. Okay, so Shuryansi was facing some problem in showing bounds, right? Did you understand how to show bounds using this? Did you get some idea, Suryansi? I don't know if she is here or not. Okay. So you can get some idea from here, Nikhil, and I think it's really easy problem. It's a sequence problem now. Okay, it's a sequence problem now. So what you can show, I guess, is here. So the limit is greater than equal to 1. I believe the limit. I don't know. I have a feeling that limit will not exist, or maybe it can exist. I don't know. This one. Okay. L equal to half into
So
L.
we have used ratio test now.
Yes, we are using ratio test.
But
No, we are
in
not.
ratio
No, 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 no,
test,
no, 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 no. We didn't use ratio test. We just did Sn plus 1 by Sn and we found out this identity.
okay.
And we formed it into a sequence format, Tishika. Now the series problem is converted into a sequence problem. Okay. I think you have to just find out whether it's bounded or not, and whether it's if it's bounded, and whether it's increasing or not. I don't think it's increasing. Is Sn greater than Sn plus 1? Okay, so if Sn is greater than or equal to, just give me a minute. So it's sort of, let me just check. N into 2n plus 1 plus 2 to the power n plus 1 minus n plus 1 by this becomes 1 plus 2 to the power n plus 1 times n. Okay. So this is something like coming from the positive side. Okay. It's coming from the positive side. See? It's coming from the positive side. So Sn, you can understand Sn is always greater than 1. Can you observe this? Sn is always greater than 1. Did you understand that Sn is always greater than 1? Did you get this part over here? Sn is always greater than 1. I broke it up and I showed it like this. And 2 to the power n plus 1 is always greater than or equal to n plus 1 after a certain point. So Sn is always greater than 1. In fact, it should be greater than 1. It should be greater than 1, not equal to. So therefore, I feel that therefore the limit will not be 1. Did you understand it, guys? Therefore, the limit doesn't exist, I guess. Did you understand it, guys? Sn is always greater than 1. We have proved that. And we have it's shown that. Now, actually, it's not so true. I'm a bit confused in here because confused in the sense I have to show, I guess, if the distance is becoming really small or not. Okay, I believe the distance is not really becoming small. And yes, I have to show over here. I think the only thing that I meant to show is that. Or just check this, okay? I don't like it'll take some time, but I hope all of you got the idea. Okay, the main idea, we have got the crux. Okay, the limit may be 1. It doesn't mean that a sequence is greater than 1 doesn't mean that the limit cannot be 1. Okay, the example is 1 plus 1 by n. All of them is greater than 1, but the limit is equal to 1. Okay, so it doesn't mean that Sn plus greater than Sn is greater than 1 means limit is um like not equal to 1. So that's the idea. Okay. So in that sense, I think what you can do is that you can check this limit. I don't know, but it feels like sometimes it does have a limit 1 or doesn't have a limit 1. So anyways, let's move to the next problem. I hope all of you got some enough hint out here. I hope this is fine, Nikhil. I hope you have got some ideas. Okay, coming back to next person, Suryangsi, I guess. Nikhil, I hope you got some idea. I'm looking for answer from your end. Okay, thank you. Okay. So why are you doing this radius of convergence? I told you it's not in the syllabus, right? Like why you're doing math problems? Math ka IIT JAM. Huh? Why you are stressing yourself out with this? Anyways, I will do the last problem of yours, which is a estimation problem. Oh, this is again a statistics problem. Okay, but I think you have done improbability convergence, so I can do this problem, I guess. I hope you have done improbability convergence, right? So radius of convergence is not there in the syllabus, Suryanshi. Okay. So I wish I could have discussed that, but I don't think I want to waste my time now during this exam. 3 months.
Which question is not in the syllabus?
You have given two questions of radius of convergence.
Yeah, radius of convergence is added in our new syllabus, no? Yeah, it is there in the syllabus.
Is that in a new syllabus?
Yeah.
Okay, fine. Okay, I didn't know that. Fine. So I will discuss this then. Are you being taught radius of convergence in our course? I don't think so.
No, sir.
Okay. Okay, then I will hold a different session for this. Okay. Thank you for letting me know, Suryanshi. Since you don't know the theory, I don't think it will be okay for us to do this now. Okay, anyways, so coming back to this, let x1, x2, xn is a random sample. Just let me announce it in the group. 1 second. Okay. So also in if you think that we have missed some topics, do let us know. Okay, we will hold some extra class, and I will of course do it in the crash courses. Fine. So let's get started. X1, x2, xn is a random sample from uniform 0, comma theta. Examine whether t is equal to product of this is consistent from for theta by is it e? Suryanshi? Huh? Hello,
So
hello.
what are you saying?
Yeah. You have uploaded a picture. I'm not understanding whether it's consistent for theta by e.
Yeah.
Okay, e means the log of that e.
Yeah.
Okay.
2.17.
Huh? What did you say last?
Exponentially.
Okay, okay, okay. Fine. So, did you approach this problem, Suryanshi? How did you approach this problem?
Yeah, I did. I found out the expectation of t.
Okay.
But then in variance, I'm having a bit difficulty.
Okay. So, how did you find out the expectation? By using that expectation of xi whole to the power that one. So it is expectation of t is equal to expectation of x1, right?
Expectation of t is equal to expectation of x1 to the power 1 by n whole to the power n.
That is x1. It cancels out, right?
No.
It's 0 comma theta, right? Or something else?
It's expecting has 0 comma theta.
Whole to the power n, whole to the power 1 by n, so it gets cancelled out, na? Oh, sorry. Yeah. Yeah, it's okay, I understand. Okay, then how did you find it out? Expectation, tell me.
I found out the expectation of x to the power 1 by n, like basic process integrating.
Okay, I understand. So you have found x to the power 1 by n. Okay, and then you have product it, right? Okay, perfect. So how did you find x to the power 1 by n, xi to the power 1 by n?
Integration from 0 to theta
Okay.
x to the power 1 by n
Okay.
by
So you can similarly find out expectation of t you have found out. Let's say expression of x1 you have found out. Now you can also find expression to the power 2 by n, right? You have found it out. It's x to the power
but
1.
then
Yeah.
here I have written for expectation I have used that expectation of t is equal to expectation of x1 x2 till xn whole to the power 1 by n, and then we can separate that as expectation of x1 to the power 1 by n
Yeah.
dot expectation of x2 to the power 1 by n.
Perfect.
So
Perfect.
that is turning out to be expectation of x1 to the power 1 by n whole to the power n, right? But then when we'll do this for
No.
variance, it's
Okay. I understand. So it's expectation of x to the power 1 by n, and here it's by theta. Okay. Then dx, right?
yes.
And here it's expected e to the power 0 to theta x to the power 2 by n by theta dx. You can do this integration, right? We need to find expectation of t. We need to find expectation of t square. T square is what? Pi of xi whole to the power 2 by n. And this is pi of xi whole to the power 1 by n. So here you find it out. How can you find it out? It's x to the power 1 by n. So it's, I forgot. I think this is the one. I think it will be to the power 1 plus 1 by n by 1 plus 1 by n times theta. I think this will be theta to the power 1 plus 2 by
I have
n.
sent you a picture on WhatsApp. Can you please check that?
Okay, I'm doing anything wrong. I will check that right away. No, it doesn't. Wait, I'm getting confused. Wait. I'm getting.
So shouldn't it be x1?
Yeah, I'm just coming to that. I'm just copying and pasting. I'm not understanding what you've written over here. Is it okay if I copy and paste it? You're right.
Yeah, sure.
Why is it taking so much time? Yes. So yes, I didn't. Can you explain this step T? This is totally correct. This is totally where this n comes. Where does this n come from?
Because we have xi's are independent, no? So we can separate that expectation of x1 to the power 1 by n dot expectation of x to the power 1 by n.
Okay. So therefore you get,
And we are multiplying it
yeah,
for n times. Yeah.
perfect. So you get expectation of t. Good. And here it's this. Superb. No, wait. Yes. So yeah, found out this. This doesn't happen this way, right? It's only for expectation it happens. You need to find expectation of t.
Yeah, I told you now I'm facing problem in variance only.
Yeah, it's okay. This is totally correct. This is not. It's where you're going wrong. You find expectation of t square. Okay, Suryanshi. You found out
That is coming out to be
that is coming out to be
square x to the power 2 by n
that is coming out to be.
theta to the power 2 by n
Mm-hmm.
into n by
Mm-hmm.
2 plus n.
And are you sure this is theta or theta to the power n? This
2
is
plus n. 2 plus n.
Okay, and this is equal to theta.
And theta to the power 2 by n. It's not 2 by n.
And the first one, is it correct? Yeah, I think
Yeah,
it's
that
correct.
one is correct.
Yeah, yeah. Okay, good. यहाँ पर भी एक होल टू द पावर n होगा ना?
Yes.
A theta square n by n plus 2 whole to the power n, right? So you can now subtract it here. Theta square n by n plus 2 whole to the power n minus whole square minus.
पर वो ये variance of t जो मैंने लिखा है वो गलत कैसे है? That I want to know.
Oh, okay. So expectation only this. So this doesn't happen on moments like this. It just happened for the expectation operator only. Okay, this doesn't. What should I say? This doesn't go out to that variance. Okay, so variance of xy is equal to variance of x times variance of y. Okay, did you understand? If you ask,
even if x and y are independent, it's not possible.
no, it just happens because of the it only happens here. Why? Because expectation of xy minus expectation of x times expectation of y is covariance of y xy. Okay, and since xy are independent, therefore it's equal to 0. Here it doesn't happen. There is no covariance formula like that, right? You understood, Suryanshi? Here it happens because expression of xy minus expression of x times expression of y is equal to covariance of xy. And since x1 and y are independent, it's equal. But here, variance of xy minus variance of x times variance of y is no such. There is no such relationship. You understood? Huh? Yes or no?
No, I'm not able to understand.
Tell me what you're not.
Like variance of xy is not equal to variance of x dot variance of y, even if x and y are independent.
No, I mean there is no result like this. Like there is no understanding. Why is this will be equal to 0? So I have proved you that since this due to this reason, this term minus this term is actually equal to covariance of xy. That's why it happens. Since x1 are independent, that means their linear relationship is also 0. Their covariance is also 0. But here variance of x minus variance of this has no meaning. Like I mean nothing to do with independence. Like why do you think this has something to do with independence? Because maybe I think you didn't know the proof of this. Did you understand?
Can you solve the bit of t from the scratch?
Ha.
From like variance of t from the scratch, can you solve it?
So yeah, you have found an expression of t square. You have found an expression of t.
Yeah.
So you can find out variance of t is equal to expression of t square minus expression of t whole square.
Yeah, that I can.
Yeah.
Yeah.
Is it fine now?
Yeah, a bit it's okay, but I have to think about it a little more.
Yeah. I think you have been thinking about this a lot of times. This is not true. And a good assignment will be to find a counter example to this, because there's no meaning with this. Okay, there's no meaning with this. Or let me just check variance of xy. I may be wrong. I'm not sure. Let's check. X and y are independent. Then they will be this. Okay. So if x and y are independent, they are coming out to be this. So you see it's mu x square, mu y square minus x. Sorry, not mu x. So you can see it from here now. This and वहाँ पर variance of x times variance of y क्या होगा? If x and y are independent, it will be expectation of x square minus expectation of x whole square times expectation of x y square time minus expectation of y whole square. You see that they cannot be equal. Can you see that, Suryanshi?
Yeah.
They're coming out to be a plus minus.
Right, I understood this part.
Okay, good. So you can find it out from here, and therefore you can find out the variance. So variance comes out to be this: theta square is constant, and so you can understand from here it's coming out to be 1 by e, theta by e. It's coming out to be. You can understand why it's theta by e, because you can understand that expectation of t is going towards expectation of t is what? Theta into theta by 1 by 1 plus e whole to the power n r hai. You can see it over here. And this goes to e. So therefore it goes to theta by e. So if you check the variance over here,
It's going to 0.
it's going to 0. Are you sure about that?
Yes, so it's 0.
How did you prove that?
So expectation of t square minus expectation of t whole square करके सारी calculations के बाद it's coming as 0.
Show me the calculation.
Both the limit will turn out to be theta by e to the
Yeah,
whole
1 by e minus 1 by.
Okay, perfect. Yes, you're right. So it's n by n, this whole to the power n. This goes to where? It's 1 by 1 plus 2 by n whole to the power n. This goes to 1 by e square, right? And theta plus n whole to the power 2n. This goes to 1 by 1 plus 1 by n whole to the power 2n, which also goes to 1 by e square. So it goes to 0. And since it goes to 0, you can understand by Chebyshev inequality, we can show that it's converging in probability. Okay. All of you understood this, guys? Suryanshi, is it clear now?
Yes.
Yeah, so I have already told Uttaran he will be doing the radius of convergence in the next classes. And I think Suryanshi, it will be best if you can ask these two problems to him while doing in the class, okay? So I will just share also the problem too in the group. So that it's minimized. Okay, perfect. So now coming to Tishika's doubt. Coming to Tishika's doubt now.
So third problem, please take that.
Okay, sure. So Suryan's all the doubts are being covered except the radius of convergence, I guess.
Yes.
Okay. The third problem, question 3.
Yes, sir. And the half of the question is in the next picture. It were 2 pages actually.
Okay, sure. So two players P1 and P2 are playing the final of a chess game, and which is consists of a series of matches. The probability of P1 winning a match is 2/3. The winner will be the one who is ahead by 2 games compared to the other player and wins at least 6 games. Okay. Now, if the player one wins the first 4 matches, for the probability of P2, P1 winning the championship. Okay, very good. So P1 has won the first 4 matches. P1, 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 and P1.
So P2 wins the first one.
Oh, I'm so sorry. P2, 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 P2. What is the probability of P1 winning the match? So understand here that the condition is 6 games and at least ahead of 2, ahead by 2 games. Okay, wins at least 6 games. Okay, current if it's yeah. Tell me, what do you have on your mind?
So in the first case, and as it is given that the ahead by 2 games, the winner should be ahead by 2 games. So first case, I found that the P1 should have won the next 6 games.
Why is that so?
So because both four and 4 games will look played, both will win 4 games till the 4 games, new games.
Okay,
P1
in
total
the
play 6 games and wins them. But for the first 4 games that P1 wins, till that it will be a draw. And 4 times P1. You can write.
I'm not getting your idea. Can you come again once?
Like the winner will be the one who is ahead by 2 games.
Yeah, and wins at least 6 games.
Yeah, the first case from the ahead by 2 games case, I found that P1 will win 6 next new games. So that he is ahead by 2 games from P2.
Okay, it can happen like this, na?
But we have to win the P1
No, you told P1 must win the.
next 6 games.
Okay, you are trying to find out the. Okay, you are trying to. Okay. You are trying to show that you're trying to find out the cases when P1 wins, right?
Yes.
Okay, fine. Good. Good. Okay, so Tishika is trying to understand that when P1 wins after this. Okay. See if P1 wins after this. Now my question is, can P1 not move win after this? P1 can move win after this, right? 7 games, 6 games.
Sir, I think we'll have to make some cases like for the next 6 games, next 7 games, then 8, and so on.
So then only he will be ahead by 2 games.
Yes. So how can you mathematically formulate this problem? You have learned a lot of probability.
I think first we can consider just 6 games, like the case when all the next 6 games are won by P1.
No,
Then the
my question is that how do you mathematically formulate this problem? So it's a probability. So probability of some random variable hoga. Tell me that. Tell me that one. Yes. So when does the game end? So you see, it's a single random variable. Okay, understand this very carefully. At any point of time, xn is what? Understand this very clear. First 4 are draw. Okay, so let's say first for a draw. Sorry, P1 wins. Okay, so we define P1 for the next one. To understand this very clearly, we are defining it random variably. Okay, it's very important. See, every game is what? Every game is a Bernoulli. So let's take the next n games after this. Next n games. So let's call it xn. It follows what? Bernoulli n comma p, and p is equal to given over here. So where p, let's take p is equal to 2/3, where it's a success of p1 winning game. Okay, so you can write as xn1. So n minus xn2. So therefore, what? xn1 makes the number of games won by p1, and n minus xn1 comma 1 is the number of games won by p2. See why I am doing this? Because when you turn it into random variable, it becomes really beautiful and easy, and you can do stuff, do expectation. And it may not work here, but I'm just doing it because it's important. And I would have done that. Section 1 is the number of games won by P1. X minus X1 is the number of games won by P2. It's in the next n games. But already P2 has won the first 4 games. Okay. So okay. So number of games won till the nth, like till the nth new game is xn over here, and here it's 4 plus n minus xn, and x0 is 0. X0 is 0. We don't know that. X0 is 0. We can define that. X0 is 0. And total games played is n plus 4. So what is the condition? The condition is that at any given point of time, the game stops. The game stops if xn minus so ahead by 2 games, at least 2 games, it's greater than equal to, right, xn minus this game stops for p1, or let's say p1 wins a game for the first time. P1 wins at stage n if the number of games won by P1 xn minus number of games won by P2, that is this, is greater than equal to 2, and xn is greater than equal to 6, right? And therefore we get that twice xn is greater than equal to 6 plus n. So xn is greater than equal to 3 plus n by 2. And also xn was greater than equal to 6. So you understood this, guys? Did you understand this? Did you understand this, guys? Yes or no? Yeah? Okay, so now tell me. Okay, I will explain it once again. So after the 4 games, and then each game till the nth step, each game is like a Burnley trial, right? With P1 winning or P2 winning, right? P1 winning or P2 losing, P1 losing. P1 wins with probability 2/3. So till the end games, it's binomial n comma p. So xn is the number of games won by P1, and n minus xn is the number of games won by P2, right? Naturally, because that's the number of games they have lost. So it tells you, the condition is asking you that the winner will be the one who is ahead by 2 games. Okay, that is this, and xn is greater than or equal to 6. Then it number of games won is greater than or equal to 6. So how do you do that? So first, for the P1 to win, as you have told in the perfect way, the number of next matches will be n is greater than or equal to 6. Okay, and let's see how P1 can win. Let's see how P1 can win. So rather, let's see how P2 can win. Can you tell me how P2 can win, guys? Did you understand, Shayantika? Can you tell me, Tishika, how P2 can win over here?
So the same way, like P2 should be ahead of P1 by 2 games.
Okay.
Like if P2 has won 4 matches and P1 has won only 2 matches, then P2 will win.
Okay. P2 will win. So let's say P2, P2, P2. So if P2 happens in the next 6 ones, if P2 happens twice in the next 6 games, if P2 happens twice, then P2 will be greater than or equal to 6, and at least twice, and P1 will be less than or equal to 4. Like, you understand? So therefore P2 wins, right?
Yes, sir.
So therefore in the next 6 games, so it's 2 2 2 2. In the next 6 games, there will be only 1 2 or no 2. Okay, let's take 2 cases then. There is, so 2 2 2 2, then there is no 2 in next 6, that is 1 1 1 1 1, or there is only 1 2. Now it can happen in 6 choose 2 ways. Let's say 2 1 1 1 1 1. Okay, so these are the two points we are trying to see when P2 can win, and therefore we are taking the opposite of it. Okay, did you understand, Tishika?
Yes, sir. So in the above case, to P1 will win.
Can you repeat again?
In the first case, like we have 6 ones, the P1 will win. Right?
In this first 6-1, P1 will win. Yes, P1 wins.
With the probability 2/3 to pass 6.
No, wait. Don't come to conclusions right away.
Okay, but in the second case, there will be a draw.
No, you have to find the probability. Okay, so it's 2 2 2 2 2, and then 1. Till this point of time, 5 5. It's right. Right? And in any other case, P2 wins. Here is one case. Here is 6 to choose case. In other cases, okay, that is 2 to the power 6 minus 6 choose 2 minus 1. This many cases, P2 wins. We have to find out this now. Did you understand, Tishika? Understand the decision tree over here?
Yes, sir.
In this case, P1 wins. In this case, we don't know. In this case, it's always P2 wins. So let's see what will happen over here now. So it's 5 games P2 has won, 5 games P1 has won. It's a logical problem now. Now after this, if 1 happens, then it's 6. If any at one point of time, let's say 1 happens, okay? 1, and let's say 2 happens. Then the 6th condition is already done. So it's 6 ones and 5 twos. Okay? 6 1 5 2. And here it's 6 2 5 1. Let's see it again. If 1 happens and if 1 happens, if 1 happens and if 2 happens. If 1 happens over here, then P1 wins. Okay? If this happens over here, then again draw. If this happens over here, it's draw. If this happens over here, it's P2 wins, right? And you see again, this will continue. So every step as you progress, the probability of you winning in the next step. So you see the probability of this is half now. Okay? Probability of this is half now. Probability of this is half now, and then again half. Did you understand the idea?
Yes, sir.
So how will you compute this?
So basically, like if you're taking total 6 games in the second case, 62 days wala part.
Yeah.
So in this 5 games will have to be won by P1, and the next 2 games will also be won by P1.
No.
P1 to
Here also it can happen. See, it's draw here. So it's 5 5 over here. It's 6 6 over here. Next, just 2 games ahead. Just you give 2 games ahead, and P1 wins. That's it. 2 games ahead, P1 wins. If just P1 wins twice, P1 wins. If it's any draw, so it's draw, okay? So probability draw can go to P1. So understand, in 2 steps. In 2 steps, what can happen? In 2 steps, draw can go to P1, draw, or P2. In 2 steps, right? Draw is going to P1 winning, draw is going to P2 winning, and draw is go to draw. This is happening with probability half, 1/4 plus 1/4, 1/4 plus 1/4. It's 1/4, it's 1/4. It's 1/4, it's 1/4. So we have to check that what is the probability of drawing goes to P1. This probability. This happens in 2 steps. We are trying to understand in general. So it can happen in 2 steps, it can happen in 4 steps. So in 2 steps, it will happen in 1/4. In 4 steps, it will happen in 1/2 of draw. It will going like this, right? Draw to P1 plus draw to P1 in 4 steps plus draw to P1, right? So what is happening? It is happening in 1/4. It is happening in half times 1/4. This is happening in half times 1/4. Did you understand, guys? Did you understand, Tishika?
yes, sir.
So it's adding up. All of you understood this, guys? Did you understand, others? Shana, Mansi, Nikhil, Paulami, Proma, Sneha, Tishika, Shuprabha. So it's going to draw to P1, draw to draw, draw to P2. Okay, it can also be done by recurrence relation. It can also be done by reconciliation. It can also be done by reconciliation. Okay, perfect. So it's solved, right, Tishika? So you know the probability of this. It's 1 by 2 to the power 6, 12, 2 to the power 6 plus this one. 6 choose 2 times 1/4 plus half into 1/4 plus half square into 1/4. Okay? Right, Tishika?
Yes, sir.
Okay, so coming back to the problem. So therefore, Tishika's doubt is a really good one doubt. So Soranx's doubt is cleared. So coming back to Nikhil's doubt. I think today was a better doubt clearing session rather than the last day because I did it to the point actually. Okay, that's another math problem. The math problems are given.
Sir, like check the last problem if it's mine. That is a statistics problem. I mean probability problem one.
Okay, sure. So the best is you ask the corresponding teachers about the next day who will be teaching you. He is your statistics faculty, math doubt clearing person. So you can ask him the solution. Okay, if you want to. Okay. So Spondan will be taking the class. You can just get that. So 10 random chords of a circle are chosen independently. To generate each of these two chords, two independent uniformly random points are chosen on the circle. It means that probably, on average, how many pairs of chord intersect? Okay, this is interesting. On average, how many pairs of chords intersect? So actually, it's a joint distribution problem. So let's say it's a circle over here. I'm going to draw a circle. Yes. The circle, and how is the point selected? The random point is selected like this. The center is there and this line is there. This point is randomly selected. How? Let's say it's the x-axis, and the angle formed, the theta angle formed, follows uniform minus pi to pi. Okay, or 0 to 2 pi, you can say 0 to 2 pi. 0 to, so for example 120 degree is this point. Okay, so according to the angle we are getting the line. Okay, and generate each of the following chords. Okay, and similarly another point is taken like this. So it's theta comma phi generates one chord. Theta comma phi generates one chord. Okay, one chord. And theta 1 comma phi 1 and theta 2 comma phi 2. So instead of doing how many pairs of chord intersect, let's understand that when does this intersect? When do these two chords intersect? it will be dependent upon this theta 1 and this number, right? And this will be a complicated combination of this, although they are independent. So you will find out. So let's say you have got theta 1 and phi 1. Okay. So can you tell me when this will intersect? Any ideas? So find a relationship, Nikhil, okay? Find a relationship. See in a circle, it's the two angles. My guess is that if one of the points is here, one of the points is here, then it's done. Then it's intersecting. The next points. So let's say when these two things are intersecting, like this, and when these two things are not intersecting, it's like this. It's not intersecting when it's like this. So when it's happening, what's happening exactly? It's happening that this angle is greater than 0 and this angle is less than this. This angle is greater than this one, this red ones, and this angle is less than this ones. Then it will happen, right? So theta 1 comma phi 1, theta 1 is this point and phi 1 is this point, is the second point, and theta 2 is this point and phi 2 is second point, phi 2. You have to just find out the condition in which they are not intersecting. You can see that if theta 1 is less than phi 2 and phi 2 is, so theta 1, phi 2 is less than phi 1, then they are not intersecting. If they're opposite, I guess. It can also happen the other way. Okay, it can also happen. Let's say, yes, it can just happen the other way also. So what is happening? If theta 1 minus theta 2 times phi 1 minus phi 2, this is less than 0, then it intersects. Did you understand, guys? This is super beautiful, right? Did you understand, Nikhil? Nikhil, did you understand? If theta 1 less than theta 2 and phi 1 less than, if they are opposite, the inequality is opposite, then it's done. Did you understand? Yes or no? The geometry. Yeah? I couldn't hear you.
Yes, I understood.
All of you understood, guys? Did you understand this part? So therefore, two chords intersect if this happens. That is, this is greater than 0 and this is less than 0. This is less than 0, which is equal to, right? Because they're IID. So by symmetry exchangeability, it's equal to half. It's equal to half. One of the signs. And they're exchangeable. So it's equal to half. The two cases, so it's 1/4 plus 1/4, that is half. Chords will intersect, the probability is half. Two random chords will intersect. So how many pairs of chord intersect? So the probability that one pair of chord intersect is half. Probability that any pair of chords intersect is half.
Sir, the last half part I didn't follow.
Sure,
Can you
sure.
please repeat?
So therefore, we have to find probability theta 1 minus theta 2 times phi 1 minus phi 2 less than 0. This is same as probability theta 1 minus theta 2 less than 0 and phi 1 minus phi 2 greater than 0, plus probability theta 1 minus theta 2 greater than 0 and phi 1 minus phi 2 less than 0. So theta 1 is identical to theta 2 is identical to theta phi 1 is identical to phi 2, and they all follows uniform 0 comma 2 pi. So by the exchangeability idea, their IID and they are exchangeable, the continuous and IID. Probability of theta 1 greater than 0 is same as probability of theta 2 less than 0. So they are equal to half, right? And these are IID. So it's half times half plus half times half, which is 1/4, which is a half. Did you understand? Did you understand, Nikhil? Huh? Others, did you understand?
Yes, sir.
Shana, Mansi, Nikhil, Paulami, Proma, Suprabho. Good. And good. So therefore, we have understood it's half. So therefore, on average, how many pairs will intersect? So two chords will intersecting, like two pairs are completely. Sorry, I should say. Let's take one pair. Yes. So two pairs completely. I think it's n choose 2 by 2. I guess so. Two pairs intersecting is is half the probability. So therefore, probability that 10 pairs intersect is 10 choose 2. So there are 10 choose 2 pairs, right? Into half. It's adding, right? Probability this intersects plus probability this two intersects plus probability this two intersects, right? So probability, the number of intersection. Okay, we can also do it like that. So expected value of intersections is indicator. Expected value of number. Understand this very carefully. Expected value of a number of intersections. This is how you deal with indicator random variables. Is what? It's expectation of summation indicator. What? There are 10 choose 2 pairs, right? Indicator pair 1, pair I, right? Indicator means it's 1. If they intersect, it's 0. If they doesn't intersect, don't intersect. So it turns out summation of I2 10 choose 2 expectation of indicator Pi, which is equal to summation of I from 1 to 10 choose 2 probability that what? Pi intersect, and we have found out that probability of Pi intersect is half, so it's 10 choose 2 by 2. Did you get it, guys? The mathematics of it? Huh? This is a really good problem. All of you understood this, guys? Yeah? Did you understand this or not? Hello? Did you understand this, guys? Nikhil, did you understand this? So I don't know, why don't you like reply?
Yes, sir.
Okay. Shana, Mansini, Ptolemy, Shuprova, Proma, did you understand this? Good. Okay, the survival function for Neo. Okay, so what is the problem with survival function? Do you know the definition of survival function, Ptolemy?
No, means what I had learned is hazard ratio or something like that, but survival function I don't know.
I think survival function is 1 by the hazard function. I'm not sure, I forgot. It's just a mathematics one. So survival function is this. I have just seen it from. So survival function is 1 minus distribution function of t. This is survival function.
And here t will follow.
T is it's like f of x, s of x.
Yeah, means it will follow x will follow exponential distribution, means the way
What?
x will follow exponential.
How do you know that?
Means in case of the hazard ratio or something we are learn for exponential distribution.
They don't go into theorems or something like that. Just tell it from this one that if Sx is defined, the survival function defined as 1 minus fx. So the question is asking its Newton is given by a straight line until the maximum age achievable m. What is the maximum age achievable if the life expectancy is f of is 60 years? So x is the, what is x? X is the age, the x life expectancy, the life expectancy actually, the life age person. So expectation of age is given to be 60. X is greater than or equal to 0. A survival function of a newborn baby is given by a straight line until the maximum achievable age m. S of x is given to a straight line. So you can understand S of 0 is one, because f of 0 is 1 and S of m is 1 minus f of m, that is 0. So therefore you can understand that what will be S of x. It passes through 0 comma 1 and m comma 0. So it's like this, 0 comma 1 to m comma 0. So it's 1 and its height is m. So it's Sx by 1 plus x by m is equal to 1. Say Sx is equal to 1 minus x by m. Okay, did you understand, Ptolemy?
Yes.
M is the maximum achievable age. That means f of 1 is f of m is equal to 1. Say Sx is this and rather fx is x by m. So if fx is x by m, this is uniform, I guess. So it's uniform. Sx is x by m, so I guess it's uniform x follows uniform 0 comma m, and the mean is m by 2, same is 120. Did you get the solution? Huh? Follow me.
Yeah, till this I have got, means it is asking that find the survival function for a 25-year-old. 25-year-old survival function means a
S
person
of 20 m.
attentionally.
S of 20 m.
S of
20 m. 20 S of 25. Sorry.
S of 25. Okay, means
So
means
it's,
after 25 years means what is the expected number of years it will survive?
yes.
Okay.
What is the probability of it surviving? What is S of x? S of x is 1 minus fx. That means what? Probability x greater than equal to x. So what is the probability to survive more than x years after 25 years? You understood?
Yes, that is good.
Okay, perfect. So I have done almost all the doubts. Nikhil's few doubts are left, and I think for the Tishika is not here, so it doesn't make sense. Okay, so let's wrap up the class, guys, and thank you for your time. And I hope you enjoyed the session. And yep, see you in the next class, and all the best for your preparation. Enroll in the crash course till now, and if you're looking for crash courses and mock test, do check out the links below. Bye bye.